Steel is everywhere, from bridges to bicycles. We need it to be strong, but sometimes we need it to be extra strong on the outside while staying flexible inside. That's where case hardening comes in. Imagine a loaf of bread with a crispy crust, but a soft center. That's what case hardening does to steel. It makes the surface hard and wear-resistant while the core remains tough and can handle shocks. This process is all about adding carbon to the surface of the steel. Carbon is like the magic ingredient that makes steel stronger. By controlling how much carbon is added and where it goes, we can fine-tune the properties of the steel for specific jobs. Whether it's a gear in your car or a tool in your garage, case hardening plays a crucial role in making sure things run smoothly and last longer. So how does this transformation from regular steel to super steel happen? It's all about chemistry. Think of the steel as a sponge and carbon as the liquid we want to soak in. We heat the steel up, creating tiny spaces between the atoms. Then we introduce a source of carbon, like a special gas or powder. The carbon atoms, now energized by the heat, wiggle their way into those spaces on the surface of the steel. As the steel cools down, the carbon atoms get trapped. This changes the structure of the steel on the surface, making it much harder than the core. The depth of this hardening can be controlled, depending on how long we heat it and how much carbon we use. The result? A piece of steel that can withstand wear and tear on the outside while still being able to absorb shocks and resist cracking on the inside. It's the best of both worlds. Just like there are many ways to bake a cake, there are different methods for case hardening steel. Each method has its own recipe, using different ingredients and cooking times to achieve specific results. One common method is called carburizing. It's like using a smoky oven to infuse the steel with carbon from a gas. Another method, nitriding, uses ammonia gas to add nitrogen instead of carbon, creating an even harder surface. Then there's cyaniding, a faster method that uses a cyanide bath. It's like giving the steel a quick dip in a special potion for a thinner but very hard case. Each method has its pros and cons depending on the desired hardness, depth and cost. Choosing the right method is like selecting the right tool for the job. It all depends on what the final product needs to do and how much wear and tear it needs to withstand. Case hardening is everywhere, even if we don't realize it. It's the unsung hero that keeps our machines running smoothly and our tools working hard. Think of the gears in your car's transmission. They need to be incredibly strong to handle the constant stress of shifting gears. Case hardening ensures they can withstand the wear and tear, preventing them from grinding to a halt. Or consider the cutting tools used in factories. Case hardening gives them the edge they need to slice through metal precisely, day after day, without dulling quickly. From firearms to engine parts, the applications of case hardening are vast and varied, demonstrating its importance in our everyday lives.